Namaste. I, JVN Nitika Chatwal, Assistant Professor in Jyoti Vidyapeeth Women's University, is here to deliver the lecture on course dispersion, which is in Physical Pharmaceutics second. So, now we are continuing the previous lecture, and now today our discussion is on evaluation of emulsion stability. How the emulsion stability can be evaluated, right? So by various steps, the evaluation of emulsion stability can be occurred. So first one is phase separation. By doing phase separation, we can make sure the emulsion is stable or not, right? And second one is viscosity. By measuring the viscosity, we can know emulsion stability. And by this, electrophoretic properties can be measured to know the emulsion is stable or not. For electrophoretic properties, zeta potential can be measured, and these zeta potential can be measured by mm, uh, any instrument. Okay, so zeta potential of plus minus 50 millivolt is minimum are needed to get satisfactory stability of dispersion. So zeta potential should be plus minus 50 millivolt to show a stable emulsion. And electrical conductivity also measured. Conductivity depends on degree of dispersion, and dielectric constant also measured to know the stability of emulsion. And in dielectric constant, inverse relationship exhibit between log of rate of increase in dielectric constant and the absolute temperature. And particle size and number analysis should also be done to know the stability of emulsion, right? Now, what are microemulsions? The term microemulsion was first introduced by Hoare and Scullman in 1943. Now it will be an MCQ question. So please write down this question, that who introduced the microemulsion term. This term is introduced by whom? Hoare and Scullman in 1943 to describe a clear solution obtained when normal oil and water course emulsions were titrated with medium chain length alcohol. Okay, microemulsion as a system of water or and amphiphilic, which is an optically isotropic and thermodynamically stable liquid solution. The driving force for their thermodynamic stability is the ultra-low interfacial tension. When the interfacial tension is this low, the interaction energy between droplets has been shown to be negligible, and the negative free energy formation is achieved, making the dispersion thermodynamically stable. Microemulsions have droplets typically in the size range 10 to 100 nanometer, and because of this small size range, they produce only a weak scattering of visible light, and hence they appear transparent. The large interfacial tension between oil and water, which is typically about 50 nanometer, is reduced by employing surfactant. However, it is generally not possible to achieve the required interfacial tension with the use of a single surfactant. Amplifiers such as medium chain length alcohols are added as co-surfactant to achieve the desired interfacial tension. Due to their amphiphilic nature. What is amphiphilic? Which have lipophilic and hydrophilic properties both. They partition between the aqueous and oil phase, thereby altering the solubility properties of these phases. In addition, the by interacting with surfactants, monoallyls at the interface, they affect their packing, which in turn can influence the curvature of the interface and interfacial free energy. Depending upon the phase volume ratio, And the nature of the surfactant used, a microemulsion can be one of three types, that is oil in water, biocontinuous, and water in oil. An oil in water emulsion is formed when the concentration of oil is low, and a water in oil emulsion is formed when the concentration of water is low. Okay, in conditions where the volume of oil and water are equal, a bicontinuous microemulsion is formed in which both oil and water exist as a continuous phase, right? So no one is in a dispersed phase. A wide variety of internal structures exists within microemulsion system. They may be spherical, spheroid, or cylindrical, rod-shaped, micelles, and may exist in cubic, hexagonal, or laminar phases. The relative amount of aqueous phase, oil phase, and surfactant required to form a microemulsion that can be determined with the aid of triangular ternary phase diagram, okay, which is tertiary phase diagram also. Now, what are the theories of microemulsion formation? Microemulsion forms simultaneously when the interfacial tension between oil and water is reduced to close to zero. The formation and stability of a microemulsion can be affected by various factors, including the nature and molecular weight of surfactant, alcohol chain and concentration, salinity, and temperature. Three different theories have been proposed to explain the microemulsion formation and stability. The interfacial mixed film theory, solubilization theory, and thermodynamic theory. Surfactants play an important role in reducing the interfacial tension in microemulsions. They can be selected based on the HLB concept or the critical packing parameters, which is also known as CPP concept, right? The CPP describes a ratio between the hydrophobic and hydrophilic parts of a surfactant molecules and is helpful in estimating the nature of formed aggregates. The CPP can be calculated using CPP equals to V upon A into L. The formula is what? CPP equals to V upon A into L, where V is what? V is the partial molecular volume of the surfactant, and A is the optimal head group area, and I is the length of the surfactant tail. When the CPP is between 0 and 1, oil and water microemulsion are formed. And when the CPP is higher than 1, then water and oil microemulsions are formed. Bicontinuous microemulsions are formed when the CPP is equals to 1. Bridge dioctyl sodium sulfosuccinate and lecithin are some of the widely used surfactants to stabilize microemulsion formulation. So what are the surfactants example over here to stabilize microemulsion? That are bridge, dioctyl sodium sulfosuccinate, and lecithin. Okay. Now, what are multiple emulsions? First one, previously we studied about microemulsion. Now the topic is multiple emulsion. Multiple emulsions are complex systems which consist of both water and oil and water emulsion at the same time. They have they can be considered as emulsions of emulsions and have been shown to be secured in cosmetic, pharmaceutical, and separation sciences. They are potential matrices for the encapsulation of bioactive compounds and for a controlled release of such compounds. In order to obtain a high yield of the inner water droplets, the emulsification of the water and oil emulsion into the outer water phase has to be performed under mild conditions. Multiple emulsions pharmaceutical application include face masking, adjuvant vaccines, and immobilization of enzymes and sorbent reservoir of overdose and treatments, and sometimes for the augmentation of external skin or dermal absorption. Multiple emulsions have been formulated as cosmetics, such as skin moisturizer, right? So, this is the important aspect of multiple emulsion that will come under cosmetology. Okay, prolonged release can be obtained by means of multiple emulsions. These systems have some advantages, such as the protection of the instant substances and the possibilities of incorporating several activities ingredients in the different compartments. Multiple emulsions have limitations because of thermodynamic instability and their complex structure, right? So this is all about multiple emulsion. Now we studied all the things about emulsions and suspension, which are both come under the category of coarse dispersion. So this topic is very important. So you should study about this topic very briefly and write a short note on emulsion and suspension are considered to be very important questions for exams. So please do study about this topic. And this is very interesting topic about emulsions and suspensions because we previously studied these topics in B Farm first year, and we prepared them also in lab scale. We prepared emulsion, we prepared suspension too. So and we studied all about emulsion and their types and microemulsion and multiple emulsions, and also studied about suspension and its core suspension, deflocculation, flocculation. And a very important question should be, what is the difference between flocculated and deflocculated suspension? So make sure you make some notes about this chapter. So thank you so much. Thank you so much. Make sure to write a short note about these topics. So thank you. In next lecture, we will discuss about the various difference between these flocculation and deflocculation substances, and we consider this is an important question or important topic for examination. So please consider it as an important topic. And after that we will study about rheology. Rheology can be studied in another section, so we will study it in later. So thank you so much for giving your cooperation. If you have any queries about this lecture, please let me know. Okay, so thank you guys.